Sampling, hey, that's a big word. Well, you cannot do data mining, you cannot do statistics without know this word called sampling. Sampling means you're going to pull a few, the keyword in here is random, right? R-A-N-D. In any software, MATLAB or whatever you name it, they have this function you can call and to randomly choose. I'm going to, in the end, I'll show you a few commands, and you can use it. There's all different sampling. The keyword is random, but make sure you understand. Sometimes you want to do sampling with replacement. Sometimes do without replacement. Depends on the sample size. If the size is huge, there's no difference because the possibility for somebody to win this huge lottery, you know, the Powerball is very few for people to get it the second time. But if the possibility is only like a card, like a stack of cards, 52 cards, replacing or not replacing make a whole statistical difference, right? That's the probability here. It depends. This stratified sampling means in each interval you sample something and to make a fair representatives. That's just like you do a demographic polling. You don't want to all focus in the Caucasians. You want a little bit of the white, a little bit of the Asian or black and everything, right? That's what you have a certain level of control. And it all depends the size and what you're doing. Now we're talking about reduction. Without reduction, and you cannot run, you can let the computer run to the next century, won't finish anything. Because don't think that we have, our computer have unlimited power. The curse of combinatorics can tell you a few choice for everything quicker, it just exploded. There's nothing the computer can do. And the one example I ask students is, you look at this cross corner, Clark Morris and the International Speedway. I just ask you how many combinations this green light, the red light, the yellow light could combine. Can you believe what a number you can have? If you don't have a pattern, that goes to $500 million, a million different combinations. It's just this few lights, 12 lines, 12 lights, 3 in each direction. You can quicker go to the 5 to the 12 power. That's how big it is. It's hundreds of millions. Think about it, a lot of traffic lights. So you need to reduce that. Let me back into this concept. That's what you have to deal with. Especially when you do natural language processing or anything artificial. When I teach the data visualization, there's two types of data visualization. One is called the scientific visualization. You deal with the physical data, like spatial temporal data. That's 4-dimensional. That's it. 3-dimensional for the space and the 1-dimensional for the physics. And you can always use a simple animation, a video, to show the behavior, like meteorologists do it. But there's another type of data, artificial data. For example, the turned in. How do you check if that guy cheated? Somebody, plagiarized other people's essay. Well, what you did is pick up those strange words. This word could be an vector of 500 words or more, 5,000 words. People are only used by particular people use what kind of frequency. And you're talking about 5,000 dimensions here. That's the curse of dimensionality when you do the natural language processing. Even though a lot of zeros, in this case, I did not use that word, zero. But I used the strange word like euloger 5 times. And I used another strange word 6 times. How are we going to reduce the dimension? And this is particularly useful when you do image processing. Because the image data, how big you talk about the pixels and the outliers. We're going to learn this later on. I only spent 3 hours. One is, they are really the same method in linear algebra, PCA and the SVD. One is principal component analysis. Another one is single value decomposition. Both methods connected to the one keyword. I want Pat to tell me what's that keyword in linear algebra. What's the?
I'm taking linear algebra this semester, sir.
Okay, you better to know that one. What is it?
Eigenvalue?
Eigenvalue, eigenvector. This eigenvalue and eigenvector, as I pointed out, it alone got 25 Nobel Prize laureates. And in the self-jointed eigenvalue, eigenvector, that concept produced 25 Nobel Physics Science Prizes. And don't mention Google page ranking. Got them, how many? They say $25 billion. Now it's way more than $250 billion because Google won the whole competition because they used the eigenvalue to do the page ranking. So that is always related with the eigenvalue. In the common word, it's called you know how to put the first thing first. What kind of important information to make the decision, you put it first. And you only select a few most influential factor instead of 100. Sometimes one rule take all. You can have hundreds of different things, you just need one rule to weigh the case and what you pick. Give an example. I told you about how do you classify the dogs and the cats. And they got like a whole bunch of choice, 26, 30 choice of dimensions. But in the end, it's only this dog here, the triangle dog here, just one single eigenvalue, which is singled out and distinguish the cats from the dogs. The rest doesn't matter. And they just all canceled out. Okay, we're going to talk about 2 to 3 hours, especially for graduate students. You definitely will deal with some high-dimensional massive data, and you need this skill. And it's not hard. Just you need to put in algebra. Period. Get the eigenvalue and eigenvector. So you need to remove some redundant features. Those are typical. The next, that's the sampling keyword, and you use R or you use MATLAB, and say random sample. That's the same keyword. That's just MATLAB. I think R used the same thing. And here, as a little exercise, we have about 50,000 of record data of the California house. And we only need a sample 100 and from the data. So you just use, this is a very good thing for you to start to observe if you try to visualize things. I put those things all in the tutorial folder, and especially there's a very good book by Martinez, that's Wendy Martinez and Angel Martinez. That's a very good book for exploring data analysis. Just means you look at the data, do a little bit of common sense statistics, you're going to find a lot of things. If you can find with data way, you don't need the data mining. But the other way is true, the contrapositive. If you cannot even find the simple things by yourself for a few data, it does not make sense to you. You don't expect it will make sense to the computer. The computer only better than you by dealing with massive data and the very complicated situation. They are quicker, but they're not smarter. You have to understand it. That is the beginning. When you prepare the data, you don't understand the data, you won't get a good result. That's a necessary condition, but not sufficient. So that's a very good book by Martinez. Martinez is using MATLAB. Cannot be better if you want to do something. Now, there's a lot of things, normalization And the same, of course, we always use this so-called summative statistics. Last time I asked you the question, how we compare the apple with the orange? Let's say just the size. Well, the best way, if you really want to compare, you will compare, let's say, how juicy they are, how sweet they are, how thick they are. Well, they are not the same fruit. It's not fair to compare them. You know, of course, if you compare how sour they are, the orange, of course, is really not sour, right? But I do want you to compare. Then you compare orange with the orange. Use the statistic to say, here is the large size orange. It's in the 95% of time in the all orange based on your data. And the other one even is bigger. This apple is a small apple. Even it's in the 25% of the time. Those are the fair comparison, right? Just like the example I asked, Tom is 5'2", but 10 years old. John is 5'4", 22 years old. Who is taller? Well, you will say, of course, John is taller, mathematically right, but statistically wrong. Because John is maybe 99% of time in his height of 10 years old when you're 5'2", right? Tom is 5'4", you might be only in the 20% of the time as an adult. Are you with me? That's a fair comparison. When you deal with data, you have to normalize data. That's key. If you deal with the stock market or bond or any security, like the mutual fund, you get a lot of very big different data, like the capital could be $1 billion. The tenure of the CEO average 5 years. How are you going to compare? And then you're going to say, hey, let's look at all the big cap. And this big cap is the 2 deviation above the average. What does that mean? Well, you have to know those concepts about the mean, the deviation, or say the variance, and the standard deviation. That's a key for you to normalize the data to compare orange with apple. Okay, coming back. Another thing is measure the similarity. I think this you can take another couple of hours to talk about it. How do you measure the similarity?